Go to the next question, the question number 11. The question is, in beta minus decay process. In beta minus decay process, try to understand, this is very important, minus sign is here, that will be make you to understand. In beta minus decay process, there is emission of. Now my dear, beta minus decay takes place in weak nuclear forces. So remember this also, that in weak nuclear forces, the weak nuclear forces takes place in the nuclear process, and the nuclear process named as beta minus decay. Now my dear, the question is something different. In beta minus decay process, there is beta minus decay process, there is emission of. Now my dear, as soon as there is a sign of minus, it makes us to understand, sir, it is electron. Because if it is plus, then it is a positron, that is anti-electron. But it is minus, then 100% it is electron. And I told you, not only electron, along with electron, anti-neutrino. In the weak nuclear process, we have explained this part, that weak nuclear forces are occurred in the nuclear process. And in the nuclear process, which nuclear process? Beta minus decay. And what is emitted in beta minus decay? That is important. That also make you to understand. That also will be taught in your class, that in beta minus decay, the emission of electron and anti-neutrino, both electron and anti-neutrino will emitted out. Okay, and next question, in beta plus decay process, this is plus. Now plus, make a understanding, it should be positron. Beta minus, electron and anti-neutrino, opposite of neutrino, that's energy. So beta, electron and anti-neutrino. And here my dear, in beta plus, it will be positron and neutrino. So remember this, my dear, we have discussed this while teaching the weak nuclear forces. I told you that weak nuclear forces are occurred, or they evolved during the nuclear process, and the nuclear process is a beta minus decay process. And when beta minus decay process was taking place, there is an emission of electron and anti-neutrino. So in beta plus decay process, there is an emission of positron and neutrino. Positron and neutrino, that is plus. So it will be positron and neutrino. And in minus decay, beta minus mein, there is electron and anti-neutrino. Right? Now let's go to the 13th question. The 13th question is, in the 13th question, my dear, so I hope you understood, minus rahega, beta minus, so common sense, sir, electron and anti-neutrino, and beta plus, then it is positron and neutrino. My dear, we have studied this in weak nuclear forces. Am I clear? I told you again and again, I am saying you that in weak nuclear forces, they are evolved in the nuclear process. And which nuclear process? Beta minus decay process, right? And beta minus decay process, when taking place, my dear, there is an emission. There is an emission, beta minus hai, so there is emission of electron and anti-neutrino. Our beta plus decay hota, so there is an emission of positron and neutrino. Now the next question, my dear, weak nuclear force is dash times stronger. In my previous question, I told you that weak nuclear force is stronger than which force? So it is stronger than gravitational force. Now the question is, how much time it is stronger? So the right answer is, it is stronger than the gravitational force by 10 power 25 times. The right answer is 10 power 25 times stronger than the gravitational force. So take care, my dear, the weak nuclear force is 10 power 25 times stronger than the gravitational force. Now next, you all know, electromagnetic force is dash times stronger than the gravitational force. You all know that gravitational force is the weakest force. It is a long range and therefore it is weakest. So rest all forces are stronger than gravitational. So nuclear forces, weak nuclear force is 10 power 25 times stronger than gravitational. Next question, electromagnetic force is how much times stronger than gravitational? So the right answer is 10 power 36 times stronger. It is 10 power 36 times stronger, my dear, than the gravitational force. So here the answer is 10 power 36 times stronger than the gravitational force. Next question. Strong nuclear force is how much times stronger than the gravitational force? Strong nuclear force, because as I said, gravitational force is weakest. So all forces will be stronger than gravitational. So weak nuclear force is stronger by 10 power 25 times. Electromagnetic force is stronger by 10 power 36 times than the gravitational force. Strong nuclear force is stronger by how much time the gravitational force? The right answer is 10 power 38 times. 10 power 38 times stronger than the gravitational force. And my dear, the next question. So strong nuclear force is how much time stronger than the electromagnetic? Because strong nuclear force is strongest force. Am I clear? So now here only you can see, you can make a logic that if electromagnetic force is 10 power 36 times stronger and strong nuclear force is 10 power 38 times stronger than gravitational. So you can think over that strong nuclear force and electromagnetic force में क्या relation हो सकता है? Sir, strong nuclear force is, I hope and I'm sure the answer is 10 power 2 times. The strong nuclear force is 10 power 2 times, that is 100 times. This can be in the exam, this can be written as 100 times stronger than the electromagnetic force, the strong nuclear force. Now my dear, you can have more option also. Weak nuclear force, electromagnetic force is how much times stronger than weak nuclear force? This can be a question. It is 10 power 36 strong than the gravitational force, and this is 10 power 25 times than the gravitational force. So among these two, electromagnetic force is stronger, and they are stronger than the weak nuclear force by 10 power 11 times. The electromagnetic force is stronger than the weak nuclear force by 10 power 11 times. And strong nuclear force is stronger than weak nuclear force by 10 power 13 times. You can see here it is 10 power 38 and here it is 10 power 25, my dear. This is 10 power 25 by gravitational force, and this strong nuclear force is 10 power 38 times stronger than the gravitational force. So strong nuclear force is stronger than weak nuclear force by 10 power 13 times. 10 power 13 times. Am I clear? So now my dear, you should take care of this thing, and the strong nuclear force and electromagnetic force have a ratio of 10 power 2 times. That is, strong nuclear force is 10 power 2 times stronger than the electromagnetic force. Okay, so I hope you are understanding. Here I have compared with the gravitational forces, and here I have given the comparison between strong nuclear force and electromagnetic force. But my dear, question can be this also, that electromagnetic forces are stronger than dash with the weak nuclear force. My dear, the answer will be 10 power 11 times. And strong nuclear force is how much times stronger than the weak nuclear force? Sir, 10 power 13 times. Am I clear? The 17th question is a very good question, very basic question. There will be 2 more questions on this. I will go for that. My dear, the 17th question is the symmetry principle used to obtain. My dear, in the nature, there is a symmetry of nature, because nature in nature there is a symmetry of space, there is a symmetry of time. Please try to understand. In nature there is a symmetry of space and symmetry of time. Now what is that symmetry means, Mache? When I talk, the symmetry principle used to obtain dash law of conservation of energy. Which symmetry principle we are using to obtain the law of conservation of energy? That's a question. Which symmetry principle? We use homogeneity of space, whether we use homogeneity of time, whether we use isotropy of space, or none of this. Now the question is, try to understand, my dear. The question is conservation of energy. You all know that, my dear, energy can neither be created nor destroyed. It can be transferred from one form to another form. Now my dear, here I mean to say that if I do some experiment right today, And if I repeat the same experiment after 1 year, my dear, it will result the same answer. Please. It will result the same answer. And you all know conservation of energy, sir. Energy conserve all time. Energy is conserved all the time. So my dear, the which symmetry principle, which same principle is used for law of conservation of energy? Symmetry. And which symmetry principle we are using, my dear, for law of conservation of energy? Do you think we are using space? We are homogeneity of space matlab, my dear, in space there is no preferred location. स्पेस में कोई प्रिफर्ड लोकेशन नहीं होता है, स्पेस में कोई प्रिफर्ड डायरेक्शन नहीं होता है. जब कोई प्रिफर्ड लोकेशन नहीं होता है तो मैं बोलूंगा स्पेस में होमोजिनिटी है, लोकेशन को लेके होमोजिनिटी ऑफ स्पेस. कोई प्रिफर्ड लोकेशन नहीं होता है स्पेस में. सिमिलरली माय डियर, कोई प्रिफर्ड टाइम नहीं होता है. टाइम इन होमोजिनिटी ऑफ टाइम, देयर इज नो प्रिफर्ड डायरेक्शन. There is no preferred direction in space, my dear. That is isotropy of space. When I say isotropy of space, matlab, there is no preferred direction. Homogeneity of time, matlab, sir, either you do the experiment today or you do the experiment after 1 year. The answer of the experiment remains same. Homogeneity of time, same. टाइम के मामले में सेम, स्पेस के मामले में सेम, लोकेशन के मामले में सेम. देयर इज नो प्रिफर्ड लोकेशन, माय डियर, इन स्पेस, कॉल्ड होमोजेनिटी ऑफ स्पेस. देयर इज नो प्रिफर्ड डायरेक्शन इन स्पेस, नो प्रिफर्ड डायरेक्शन इन स्पेस, कॉल्ड आइसोट्रॉपी ऑफ स्पेस. And homogeneity of time, my dear, whatever experiment we are doing today and after 1 year also, the result of the experiment is same. Today and after 1 year, there is a span, 365 days span of time, my dear. But there is no difference in the answer, result in the answer. Law of energy conservation is remain today same, tomorrow same, day after tomorrow same. So the right answer for this question is the symmetry principle which is used to obtain is homogeneity of time for the law of conservation of energy. We use the homogeneity of time principle, my dear, to prove the law of conservation of energy. The symmetry principle which is used is homogeneity of time to obtain the law of conservation of energy. Homogeneity of time, that is, time remains same. My dear, time remains same means for any time, my dear, the energy remains conserved. That is called homogeneity of time. Am I clear? That is, my dear, at every moment, today I do the experiment, or tomorrow I do the experiment, or day after tomorrow I do the experiment. I mean to say energy is remain conserved. So my dear, which symmetry principle I am using? Homogeneity of time. Homogeneity of time. So remember this, that the symmetry principle which is used, my dear, is the homogeneity of time to obtain the law of conservation of energy. Don't forget that it is homogeneity of time. And I explained what is homogeneity of time, my dear. In space, my dear, whenever we go, my dear, in space there is no preferred location, no preferred direction, and no preferred time. That is the symmetry of space, time, and other type of symmetry which is occurred in nature, my dear. So remember this question very well, that to obtain the law of conservation of energy, we use the symmetry principle, and that symmetry principle is the homogeneity of time. And I explained also, my dear, what is homogeneity of time. that sir, today you perform some experiment at one place and day after tomorrow you perform the same experiment at same place, it will give the same result. Am I clear? And this is what is the law of conservation of energy based on, that is homogeneity of time. Now my dear, let's go to the next question. The next question is, now my dear, the next question, the question number 18 dash, because I have told you that symmetry principle, I explained there is a symmetry principle, homogeneity of time, homogeneity of space and isotropy of space. What is homogeneity of time? Sir, there is no preferred time in space, my dear. There is no preferred time that like in space or today whatever I am doing, the same thing will be happen after 1 day, after 2 day, after 3 day, matlab it is homogeneity of time. What is homogeneity of space? Sir, there is no preferred location, space, in space. There is no preferred location in space. And my dear, that is called homogeneity of space. And what is isotropy of space? Sir, isotropy of space is that there is no preferred direction. So my dear, here the question is, which symmetry principle is used to obtain law of conservation of linear momentum? Linear momentum is related to the space, my dear. But what space? That linear momentum is what? Only one thing is important. The total force should be acting on the system should be 0. And it gives a conservation of linear momentum. So my dear, when we talk in space, sir, we know that there is no preferred location. There is no preferred location. So principle of linear momentum will be based on that principle where there is no preferred location in space. And therefore, my dear, when I say symmetry principle which is used to obtain the law, because linear momentum, when I say, my dear, the total momentum before collision and the total momentum after collision is remain constant. The total momentum before and the total linear momentum after is remain constant. So my dear, the answer for this question is, the right answer for the question is homogeneity of space. And what is homogeneity of space? Sir, in space there is no preferred location. By the law of symmetry, by the symmetry of nature. And when we talk a linear momentum is conserved, they obey this homogeneity of space concept. कि मैं लोकेशन में कोई भी लोकेशन पे करूं, the linear momentum that is before momentum and after momentum, momentum that is after collision and before collision, the total momentum is remain same. मैं कोई भी लोकेशन पे करूं. So that is related to the homogeneity of space. And energy में क्या था? मैं कोई भी time पे करूं. That is homogeneity of time. Please. कितना सिंपल है. लॉ ऑफ कंजर्वेशन ऑफ एनर्जी क्या था? सर आज करो, कल करो, परसों करो, कभी भी करो, एनर्जी रिमेन कांस्टेंट. सो देयर इज नो प्रिफर्ड, सर देयर इज नो चेंज इन टाइम. This is remain same in all time, remain same in all time, remain same in all time, remain same in all time. That is conservation of energy, homogeneity of time. Remain same at all location, remain same at all location. That is homogeneity of space. And remain same at all location, that is linear momentum remain conserved at any location. उसका कोई लेना देना नहीं है. That is the symmetry of principle, my dear. So remember this, sir. Energy conservation, homogeneity of time. आप कोई भी टाइम पे करो, law of energy is conserved. So a homogeneity of time मतलब sir time कुछ भी हो, that it remains same for every moment, my dear. Energy will conserve. Homogeneity of space, sir, कोई भी preferred location, because there is no such preferred location in space. So whenever you do this, my dear, the conservation of linear momentum will take place. It's nothing doing that, sir, preferred location होना चाहिए. for linear momentum. सर बिफोर एंड आफ्टर कोलिजन होने के बाद मोमेंटम कांस्टेंट होना चाहिए, कोई प्रिफर्ड लोकेशन ऑफ स्पेस का होना जरूरी नहीं. That is homogeneity of space. And the next is, which symmetry principle is used to obtain law of conservation of angular momentum? Angular momentum is related to direction, my dear. Torque. When torque is zero, torque, that is no preferred direction in space, sir. No preferred direction. वही law इसको govern करेगा जहां पे कोई preferred direction नहीं है. That is isotropy of space is the right answer. So my dear, these are the three very important objective I have given the earlier, that law of conservation of energy is governed by the principle that is homogeneity of time. कि मैं कोई भी टाइम पे उसको करूं बच्चे, energy will conserve, homogeneity of time. That is, there is no preferred time in space. Whenever you do anything, any time बच्चे, your energy will conserve. Similarly, my dear, there is no preferred location in space. Location, that is related to space. No preferred location in space. And my dear, if there is no preferred location, nothing doing with the principle of law of conservation of linear momentum. Linear momentum को conserve करने के लिए कोई specific space location नहीं होना चाहिए. That is the symmetry principle, my dear. So the principle of homogeneity of space is used. And similarly, my dear, the law of conservation of angular momentum, so simple, sir. There is no preferred direction. So remember, if I say no preferred location, that will homogeneity of space. Everywhere it is same, bache. The law of linear momentum will take place at any place. At any time, the law of conservation of energy will take place. And at any, since in space there is no preferred direction, so my dear, the law of conservation of angular momentum will take place on the basis of no preferred direction in space. That is called as isotropy of space. So take care. This is the answer for this, isotropy of space. So please take care of these three basic very important question, that to govern the law of conservation of energy, so there is homogeneity of time. You do at any moment, any time, my dear, your energy is conserved. Sir, for law of conservation of linear momentum, sir, there is no preferred location. So there is a homogeneity of space. At any space, my dear, at any place, at any location, at any place, the linear momentum is conserved. Only important is the total force acting on that will be zero. And law of conservation of angular momentum, so in space there is no preferred direction. And you said torque is zero. Am I clear? So there is no preferred direction, my dear. So of course this law will be conserved. This law will be taken place because in space there is no preferred direction, and that is called isotropy of space. तो जहाँ पर आइसोट्रॉपी ऑफ स्पेस होगा वहाँ पे ये लॉ गवर्न करेगा एंगुलर मोमेंटम. जहाँ पे होमोजेनिटी ऑफ स्पेस होगा वहाँ पे लॉ ऑफ लीनियर मोमेंटम गवर्न करता है, और जहाँ होमोजेनिटी ऑफ टाइम होता है वहाँ पे लॉ ऑफ कंजर्वेशन ऑफ एनर्जी गवर्न करता है. और मैंने आपको समझाया बेटा, आज आप एनर्जी कंजर्वेशन एक्सपेरिमेंट करो, कल करो, एक साल बाद करो, एनर्जी उस प्लेस पे कंजर्व ही रहेगा. अगर जो आज है वो कल भी रहेगा, परसों भी रहेगा. दैट इज होमोजेनिटी ऑफ टाइम. लीनियर मोमेंटम, जिस स्पेस में आज लीनियर मोमेंटम कंजर्व है, जिस लोकेशन पे, जिस प्लेस पे, मेरे बच्चों नेक्स्ट लोकेशन पे, नेक्स्ट प्लेस, नेक्स्ट उसी लोकेशन पे, वही प्लेस पे, बिकॉज कोई प्रीफर्ड लोकेशन नहीं है, कोई प्रीफर्ड स्पेस नहीं है, लीनियर मोमेंटम विल रिमेन कंजर्व. And isotropy of space is nothing but a preferred direction in space. So there is no such direction specified in space, my dear, and the law of angular momentum is governed on this basis, isotropy of space. Now, my dear, there is 4 basic question I have written, 5 basic question. Please take care. This all 5 question has one answer. And that is the reason why I have taken. This can be anything in the exam. I have not put the option for this question. I have not put any option for the question because the answer is common. And what is the question? The nature of intermolecular van der Waals forces. What is the nature of van der Waals forces? Question is the nature of van der Waals forces, the nature of elastic force in spring, the nature of force in taut spring. Taut string matlab tight string. Taut means tight. Stretched, taut. That's taut. T-A-U-T. Taut. Tight. Stretched. So what is the nature of force in elastic spring? What is the nature of the force in taut string? What is the nature of the force? Which nature of force in force of friction? Which nature of forces occur in contact forces between the two bodies? My dear, the answer is one and one only. That is electromagnetic forces. Electromagnetic forces. Electromagnetic forces. Electromagnetic forces. Electromagnetic forces. And here also electromagnetic force. ये सारे के सारे फोर्स जो आप देख रहे हो, van der Waals फोर्स या फोर्स इन इलास्टिक स्ट्रिंग, फोर्स इन टॉट स्ट्रिंग, फोर्स इन फ्रिक्शन, force in contact between the two bodies, my dear, that is contact force between the two bodies, they all these are electromagnetic force in nature. They all are electromagnetic force in nature. Out of this any 5 question, my dear, the answer is one and one, only one. The nature of force in all these things are electromagnetic in nature. Van der Waals forces are electromagnetic in nature. Elastic forces are electromagnetic in nature. Taut string में जो forces होता है are electromagnetic in nature. The force of friction are electromagnetic in nature, and the forces in contact forces between the two body are electromagnetic in nature. So my dear, here electromagnetic forces I have written. I can write electromagnetic nature. The nature of intermolecular van der Waals forces are electromagnetic. They all are electromagnetic. They are electromagnetic in nature. So take care, my dear. This is the common answer, that in all these example, all these, my dear, van der Waals force bolo, elastic forces bolo, in spring, taut string में force बोलो, forces in friction बोलो, forces of friction, and contact force between the two body, all these forces are electromagnetic forces, and they are in nature. They are electromagnetic forces which is occurred with all this, my dear, and they all are electromagnetic in nature. They all are electromagnetic in nature. One common answer. Please take care. Any example, the forces are electromagnetic in nature. Next, my dear, the strong nuclear force is dash times stronger than the weak nuclear force. So I have told you all that weak nuclear force is 10 power 25 and strong nuclear force is 10 power 38 times. Weak nuclear force is 10 power 25 times stronger than gravitational force, and strong nuclear force is 10 power 38 times stronger than the gravitational force. So among strong nuclear force and weak nuclear force, the right answer is 10 power 13 times. The right answer is 10 power 13 times. So 10 power 13 times stronger than the weak nuclear force. And my dear, similarly here the electromagnetic force are dash times stronger than the weak nuclear force. Electromagnetic force are 10 power 36 times stronger than the gravitational force. And weak nuclear force is 10 power 25 times stronger than the gravitational force. So you can think over that electromagnetic force is how much times stronger than the weak nuclear force. The answer is 10 power 11 times stronger than the weak nuclear force. So remember, my dear, these are the very important question I have written here on the board. Especially question number 17, 18, 19, that which basic principle, which symmetry principle we are using for law of conservation of energy, law of conservation of linear momentum, and law of conservation of angular momentum. And answer is, for law of conservation of energy, sir, it is homogeneity of time. Homogeneity of time. Am I clear? For law of conservation of linear momentum, sir, it is homogeneity of space. And I told you what is the meaning of homogeneity of space. When you talk about in space, there is no preferred locations. And similarly, my dear, for linear momentum, there is no preferred locations required. So it is based on homogeneity of space. For law of conservation of energy, my dear, there is no time required. Any time the energy is conserved. So it works on homogeneity of time. Similarly, my dear, in angular momentum concept, we want a direction concepts. Am I clear? Torque is zero. So my dear, when this law of conservation of angular momentum takes place, when there is no preferred direction, and that is nothing but isotropy of space. आज के बाद आपको कोई पूछे what is isotropy of space, immediately say, sir, in space there is no preferred direction, that is isotropy of space. Sir, what is homogeneity of space? Sir, in space there is no preferred location. That's all, bache. And here I have given the 5 common question, that if I say van der Waals forces का क्या nature है, elastic force in spring का क्या nature है, taut string और stretch string और tight string या rope का क्या nature है, force of friction का क्या nature है, contact force between two body का क्या nature है. Sir, all are electromagnetic forces in nature. They all are electromagnetic forces in nature. Am I clear? So take care of any of these 5 example can be asked in the exam, and all the answers are common. They are electromagnetic forces in nature, right? And here I have given the comparison: strong nuclear force with weak nuclear force, and electromagnetic force with weak nuclear force. Now let's go to the last 4 question before I'll wind up. Before I'll wind up this one, the last 4 question. Now my dear, before I'll give you questions for your revision test from the same chapter, I will upload in the next YouTube video, I will upload the revision test questions, and you will get those questions according after this only, immediately after this, which you have to do it and send it to my WhatsApp. My dear, that answers I will send it to you after 1 day. Now the question is over here, a supposition that is put forward. The 27th question, I am writing 30 questions to you all, and 20 questions I will give you for practice. So in all 50 question was my thought to give you. So 27th question, a supposition that is put forward as a probable solution to a natural phenomena. My dear, in this entire thing, a supposition, there is a word supposition, there is a word consideration, that is put forward. Matlab we are doing supposition, my dear, for our probable solution. Probable means probably. So is put forward as a probable solution. मैंने जो supposition लिया उसको मैंने बोला हाँ ये probably है. मेरे supposition को मैंने बोला is put forward as a probable solution to a natural phenomena. कोई नेचुरल फिनोमिना था, मैंने अपना एक सपोजिशन लिया और बोला ये प्रोबेबली हो सकता है ये फिनोमिना में. माय डियर, दैट इज माय सपोजिशन. आई एम सपोजिंग, आई एम कंसिडरिंग, एंड दैट इज हाइपोथेसिस. दैट इज नथिंग बट दे आर कॉल्ड हाइपोथेसिस. सो व्हाट इज हाइपोथेसिस? हाइपोथेसिस इज नथिंग बट अ सपोजिशन, a consideration. So what we are doing, we are supposing and we are put forwarding as a probable solution. हम suppose करते हैं और उसको हम probable solution मान लेते हैं. हाँ, probably यही solution है for this natural phenomena. So that is, my dear, that is hypothesis. That is consideration. That is supposition. That is hypothetical. So that is hypothesis. So try to understand the question of this kind, because we are doing the word physical world. This kind of a question is there. If I do any supposition, if I do any consideration, and I put forward as a probable solution for a natural phenomena, my dear. So that is your hypothesis. That is not a real one. That is your consideration. That is hypothetics. That is hypothesis. So important word is supposition to catch this, to understand. Second, my dear, a thought experiment in physics is one. You are doing an experiment in your thought. So what is the thought experiment with physics? To whom we call a thought experiment? The one which is neither theoretically possible nor experimentally possible. That is a thought experiment of physics. So whenever we say, sir, this is the experiment in thought of physics. So my dear, that once I said it is thought of physics. So my dear, that particular experiment is neither proved experimentally nor it is proved, my dear, theoretically. So remember, to whom the physics called a thought experiment, those experiments which are neither proved theoretically nor proved experimentally are called a thought experiment in physics. I hope it is clear, my dear. So first one was supposition, which is put forward as a most probable solution. कोई भी supposition को probable solution मान लेते हैं किसी natural phenomena में, यहाँ यही probably यही solution है, but वो supposition था बच्चे, that is hypothesis. Second, my dear, कोई भी thought experiment physics में है, so that thought experiment sir, they are neither proved theoretically nor we can prove experimentally. Right answer is B. The third one is, my dear, the book titled Principia. You all know that the book title, I hope this is a very famous book. I'm sure about it. Many of you are knowing this book very well. So the book title Principia, was written by a great scientist called father of motion, that is Newton. Newton has written this book, and the title of the book was Principia. Am I clear? Principia. It's on the governing the laws of motions, my dear. So the book titled Principia was written by a great scientist, that is Isaac Newton, is the right answer for the question, my dear. Remember this also, because physical world we can ask you this sort of question, like the book title Principia. I am giving you the 20 questions as a homework. There I will say, I will put all those questions: which scientist has got Nobel Prize, how many scientists got twice Nobel Prize, who has discovered what was discovered by Michael Faraday, what was discovered by Einstein for which he got Nobel Prize, what was the discovery of C.V. Raman. So these are all the questions, 20 questions as my homework which I am assigning you. So I have taken one question of this kind, that the book title Principia, my dear, this is very famous question, most of you know also. The book title Principia, this is there in our library also, my dear, this book. So the book title Principia was written by a great scientist, that is Isaac Newton. Now next is the last question. It is more important to have beauty in the equation of physics. You all know our physics carry equations, my dear, and the beauty lies in the equation of physics because it makes us to understand mathematically. So the beauty of the physics lie in the equation as compared to experiment. That's a point, my dear. This line states, it is more important to have beauty in the equation of physics than to have them agree with experiment. मतलब equation से ज़्यादा beauty होता है as compared to agree with the terms with the experiment. हाँ ऐसा है, experimentally दिख रहा है, but वही अगर equation से prove करें तो उसकी कुछ beauty अलग होती है, my dear. This is the statement made by a great scientist, and all you know, I hope you know, the name of the scientist was Dirac. Not Dirac, it is Dirac. The name of the scientist was Dirac, who find that the beauty of physics lie in the equation. The beauty of physics lie in the equation of physics, my dear, as then compared to then the experiments, my dear. It was said by a great scientist called Dirac. Am I clear? So remember, Dirac was the scientist who told this, who agree with this statement, who feel it is more important that the beauty of physics is in the equation of physics as compared to the experiment to prove that one. It will be proved by equation. It will be much beauty. It will be much better than to prove anything with by experiment. This was well said by a great scientist, and the name of the scientist was Dirac. So these are the 30 questions, my dear. So all the best and Jai Hind you all. From my side for this physical world, I am giving you this 30 questions. Please go through with everything, all 30 questions, and I am sending you more 20 questions as for your homework. And for the answer of those questions, I will put it in the WhatsApp on the Common 11 Science group. Please go through with the answers also. After one day, I will put the answers. First you try your all answers, and then after one day I will put that 20 questions ka answer. That 20 question, this is 30 question which I have solved in front of you to you all. The next 20 question which I am uploading on YouTube is for your homework. You search the answer, you find the answers of those questions, and I will let you know the answers after one day through my WhatsApp, through our group of 11 Science, which is made by Sunbeam Sun City. Jai Hind you all, and thank you all. This is my request. Everybody of class 11th A, 11B, go through with these questions. This is a kind of a revision questions for your unit test also. The same manner, the same pattern. Am I clear? More or less I told you that the MCQ will turn into true or false also. The objective, the fill in the blanks will turn into true or false. No issues. But the similar pattern, the questions will be on similar pattern. That's all. Thank you all, and Jai Hind.